All right, today we're going to go through Graphical Robot C and go over the different options in there for building a program. So to get into Robot C, you should have on your desktop an icon that says Robot C for VEX. This is the one where you're going to be writing code in C, which is a written language. And there should be one that's more rectangular that's called Graphical Robot C. We're going to open that one. This is the one that uses the code blocks that are kind of um, each represent a different command. And so you kind of just drag and drop them instead of having to write the code and make sure it's all formatted correctly. When you open it up, it should open at the start page. And from here, we're going to click on New File. This should open a blank file. It should have some kind of default name. And then on the left here are all of, or most of your functions. They're categorized by their use and they're color coded by their uses. So program flow, these are loops or kind of macro commands that either are conditional statements or repeat things. They don't actually execute any code. It just is conditional for how the code works that's placed within these. So like when you put these into the program, you'll see how it kind of has a little horseshoe shape. So the repeat command will repeat however many times you specify up top here any code that goes inside of it. The repeat forever is just you're replacing the one with effectively infinity, and so this would just keep repeating. If you were building a program that was going to just run indefinitely, you would start with this and build your entire code within this command. Repeat until, again, loops the command, so think of these as looping parameters. But this one uses a variable, so some kind of function, so you can use any of your sensors, and when a certain condition is met, it'll stop repeating. So as long as whatever your condition you set up is, so you'd use some kind of timer, a variable, sensor data, or motor if you're measuring distance, and then you could change your logical symbol, so equals, doesn't equal, greater than, less than, equal to, and then you'd set a value. Remember all your sensors have different values, we'll go over those again, but the code would loop until whatever parameter is met, and then it would move past it. The if statement only executes what's inside if whatever your condition is met when it reaches it. So it doesn't matter if it's met later. Once it passes it, that's it. But if the condition is met, it'll do what's inside the loop, and then it'll move on to the next section. If else allows you to select two different conditions. So your if statement would be whatever you set it to at the top. And if that is not met, it'll do the else. So when you reach this point, it only does one of these two things. It will never do both. It'll, depending on if the condition's met, it'll do the top portion here. If it's not met, it'll do the bottom portion. That's why if or else. So when we went over logical expressions earlier, think of this as an or statement. So it's going to do one or the other, not both. Wait until. This doesn't have a horseshoe. This just pauses the program until a certain condition is met. So if you want something to stop at a line on the ground and wait for 10 seconds or wait for a certain parameter to be met, you set that, and then basically it's a pause command. It'll pause the code at this line until this value is met and then continue moving. It doesn't loop anything or go into any specific code. It's just kind of a pause command. And then this green one is comments. If you're writing in regular C++, you see how there's these two slashes. In typical C, you use two slashes, and it won't execute anything that's written there. It's kind of color coded. It'll become green text, but in here you can explain what's going on. And the use of this is if you put these, if you were to put this comment in front of whatever this loop was going to do, you could explain what either comes around it or after it, and it just helps if someone else is looking at your code, or if I'm grading your code. It makes it easier to follow. and it allows you to remember what your thought process is as you go through it. If something doesn't work as intended, you can kind of write in the comments what your intention is, and then I can look at the comment along with the code and see if maybe there was some kind of disconnect between what you thought it was going to do versus what it's actually doing, and it helps making troubleshooting way easier. So hopefully you guys um, use this a lot. Um, Anywhere you have something that's not very obvious, I would expect you guys to have a comment kind of explaining what that part of the code is doing. The next section is variables. So what these variables do is they create um, basically variables. These are like values that you can set to either a number, positive or negative. So you can edit a variable that already exists, or else you have to create a variable. When you add a variable, you need to name it. So once you create a variable's name, so I'm just going to name it test1. I can say test1 is equal to 5. And now, like if we were to like look for a variable, now it shows up under our variables. So once you start creating variables, you have to create them at first, but then once you create it, you can use it anywhere in the code. Now, obviously, if you're creating a variable, you need to make sure it's before where you would use it, because the code goes in order. So it goes line 1, 2, 3, 4, 5 in sequence. If I specify this variable down here, this if statement up here is not going to realize that the variable is equal to 5 yet, because I haven't basically set it to 5. Everything, I think, defaults to 0 or 1 or something like that. So it'll know the variable exists, which is why I'm able to select it. But if I were to say if the variable is equal to 5, it would probably skip this over because I didn't specify that the variable is 5 until after that portion of the code. So variable number allows you to set a variable equal to a number that you specify, so that's a fixed value. Variable value lets you set it equal to a value. So again, we can use test1 again. And the thing is, if you're using the same variable and you're changing its value, it's going to be whatever value it is when you first specify it, and then when you change it, it'll change that variable. And so then when you hit a later portion of the code, it'll use whatever the most recent value that you set that variable equal to. So the value is just you can basically set the variable equal to some kind of sensor data. So this allows you to remember some kind of sensor value. You could basically write some kind of code to remember the max value, because if you have something where the value is fluctuating, you can have it only record and save the value if it's greater than the previous value. We'll get into that later. And the last one is variable expression. So now you can take the variable, and this is basically an equation. You can take a value. So if you want to take that potentiometer again, you can multiply it, add it, subtract it, or divide it. So you can divide that value by 10. And this just allows you to convert. This is essentially a formula that you can kind of convert if you're changing units or turning it into something that's more useful. Because most of the sensors give you what I like to call raw data. So it's just a number between some raw value. So like for the potentiometer, I think it goes like 0 to around 5,000. Now the potentiometer can spin from 0 to 180. So if you take that 5,000 spread and divide it by 180, then you know how many values per degree. So you can convert, if you want, the potentiometer to its degree. So if you were to grab a calculator, you could plug it in. So 5,000 divided by 180, that means you'd have about 28 values for your potentiometer reading per degree. So this would convert it basically from its raw data into degrees. So that's where something like the equation would be useful. Now there are some simple behaviors, so forwards and backwards, these are macro commands. This will spin a motor, so you have to specify what port each of these values, so let me go up here. So if you see how right motor, left motor, port 2, port 3, port 6, input 6, 7, 8, digital 1, 2, 3, everything is plugged into a certain port on the VEX controller. So you have to specify what are you doing here? So forward 1 rotation, are we doing 10 rotations? And then this is the speed. So this is, I think, 0 to roughly 100. It's a scale of like percentage. It's not like the raw output speed. Turn left, turn right. Now these are kind of, like I said, macro commands. You can use the individual commands down here. These are specific motor commands. So you could use, instead of doing forward, you can take the set motor command, use it twice. We're going to specify the port values. So we have right motor, left motor. The reason why this is all set up, because if you remember back when we kind of worked in this earlier, we had our motors and sensors set up. So we created the name of everything and we put it to where it is, and we told the program what kind of sensor it was. So we have our motors, our analog sensors, which are our inputs 1 through 8, and then we have our digital sensors, which are digital 1 through 12. And on the VEX controller, it's all labeled. So, we have to specify right motor, left motor, it's on what port it's on, what kind of motor it is, does it have a built-in encoder, are they reversed? So, this will ask you all the questions that you really need to know, and you just need to make sure that you're selecting the right type of encoder. So like an encoder, it's an encoder, it takes up 2 ports. The touch sensor is just, touch. So you have to just make sure you know which category each sensor falls into, and then make sure that you're setting it up to where this all matches the ports that you plug it into on the VEX controller. The stop all motor command basically just stops everything. It stops all outputs. The stop motor command, you can specify to stop a specific motor. So if like you had an emergency stop, the stop all motors would basically, if a certain value was, if it was about to run into something, it would just stop everything and kill power to everything, and kind of like as a safety cutoff. So, set multiple motors. Again, you can choose up to 4 different motors that you want to run. So if you want to go forward with your 2 motors, you would check right and left, and you could, just leave the rest at no motor. Instead, it's speed. So motor commands, kind of, for the most part, they're pretty self-explanatory by like what the name is on them. Remote control, we're not going to really use these. We're focusing on programming them. Yes, they do have the controllers. What this does is it allows you to map either buttons on the computer keyboard to essentially drive the robot around, or you can hook it up to a joystick, or with the remotes that come with the VEX kits. Again, we are not going to be using those, so you guys can either close it or ignore it. Timing. The wait command is, again, just like the wait until. It's kind of a pause command. You can basically, it'll just wait and pause the program here for however many seconds, milliseconds, or minutes you want it to pause for. And for certain things, there's timers. So you have, there's different variables for your different timers. So if you want to set, like, under these orange commands, there's timers. You can choose a timer. And after you use the timer, it's not going to automatically reset it. It's just going to keep running in the background. So you have to reset that timer if you're going to want to reuse it. So that's where you would reset it, and you select which of the timer variables. So like if that's T1, you'd want to reset T1 before you use it, so it starts at 0. Or else all the timers essentially start when the program starts, and they just keep counting up indefinitely. Line tracking. Again, these are kind of macro commands that you can use to use those infrared light sensors to track a line. I previously showed you guys how to do it with if statements, and again, I'll go over it again, how to do it with nested if statements. So we probably won't use this much, but like basically this helps you steer left or right depending on the data. This also only works for one command on the robots. We have 3 on the bottom that you can use. What else do we have? Reset a sensor. So if you need to reset a sensor data or something, you can do that. And then you could play sounds. I'm not sure if the controllers themselves have built-in speakers, or you would need to hook in an external speaker, but you could always try this, like a startup noise. So these are just like different sounds, like probably like nothing too fancy, like like old telephone beeps or tones or buzzes. Or a tone, this would be the tone in kilohertz. So you would just set that, and then this is how long it's going to play in milliseconds. So this would just make a single like buzzing tone at one level of sound frequency. So depending on what you want to do, again, you can kind of place these at certain points in your program, and depending on if you hear the sound or not, you can tell if you've basically hit that part of the program, and that again is useful in being able to kind of follow the progression of the code without having it being plugged into the computer. And it kind of helps you troubleshoot again if something happens where it's not doing what you intend. Again, you guys will have to experiment and see if the controllers have built-in speakers to do this. Since you're not specifying an output, I would guess yes. So that's basically everything on the left. Most of what you're going to do is using these orange looping functions, whether it's repeat or if statements or waiting, and then controlling your outputs, which would be our motors. So we have for those robots that we have built, we have a left and a right motor, and then we have an arm motor. So there's the arm motor. If we had more motors, again, we have up to I think 10 different ports that we could set them all up with. But right now we only have those 3. Actually, there's 4 because then there's the claw motor on the end of the arm to open and close. So those are our 4 outputs, and then all of our inputs are all of these sensor datas. So the potentiometer, the light sensor, accelerometers, the encoders on the wheels, the touch sensors, the sonar, the limit switch, the light, no, we already said light sensor. So basically, the way this works is depending on what it's reading and what you want it to do, you basically set all this up, and you get, based on the inputs, you then have it, you decide what you want the desired outputs to be, and then that's how this works, and it just, works through the code. If you have it repeat, it'll then go back to the end. If not, once it hits the end of the code, it just stops. So if it were to just run this, once it hits line 34, it sees there's nothing left, and it just stops. Then you would have to, restart the controller, and it would then start that program again from the beginning. So again, the do before you get in here. You don't want to just get in here and start playing around. You need to think what you want your outcomes to be. What are the inputs that you can use to help you achieve those outputs? Think of the sensors that will give you data that helps you make decisions. This is essentially the computer is going to be making a limited amount of decisions. Each of these loops, if statements, or repeating, they're all decisions that's being made based on values. So based on data and what what your threshold is, it's going to make a decision to either do something or not do something or continue doing something. So you have to think about what you want basically your gates to be. So the best way to start off is, 1, think of the purpose and what you want the end result to be, and then you work backwards. A second is basically building a flow chart. So writing down the sensors that you think are relevant, what kind of data they're going to give you, and then how you can break up that data and use that data to help you get from your starting point to your ending point. After you have that in your head, then coming in here and basically writing the code becomes way easier because you have your flowchart, and the flowchart is essentially the code just in picture form. So then you should have a better idea of what you need to put together. So this has just been a brief overview going through all the different commands. In the next video, we'll go over how to build a simple if-else statement using sensor data and getting some kind of result.